All right, so problems 8 through 13 give us some information, and they want us to rewrite based on the symbols that they have given us. So they tell us that P is that points X, Y, and Z are collinear. What does that mean? They're all on the same line. Oh, look at that. Q points X, Y, and Z lie on the same line. So they give you some different things that they want in symbols for you to write. So the first one with 8, they want us to write Q implies P. So we would say something like, if points X, Y, and Z lie on the same line, then they are collinear. They want us to do not P. So this would be points X, Y, and Z are not collinear. P if and only if Q. So this is a biconditional one. Any idea how I would write this one?
Points X, Y, and Z are collinear if and only if X, Y, and Z lie on the same line.
Yep. So we've got points X, Y, and Z are collinear if and only if they lie on the same line. And obviously this could be written either direction. Biconditional can be written that way. If it was like Q if and only if P, then I would want to say in the other part, if points X, Y, and Z lie on the same line, then they are collinear. So like use the first part to specify like exactly what you're talking about, and then you can be a little bit more generic in the second part. All right. Given that this statement is in the form of P implies Q, write what P and Q like are individually. Then write the inverse and the contrapositive of P implies Q, both symbolically and in words. So these are not like, these are more like practical things, not like math notation things. I don't know. Anyways, you'll see what I mean in a second. So 16, if the fuse has blown, then the light will not go on. All right, so if this is written in the form P implies Q, what is P?
Fuse is blown.
Yep. The fuse is blown. What's Q?
The light won't turn.
Yep, the light won't go on. I don't know why they didn't say turn instead of go, but, you know, whatever. All right, so in symbols, okay, first, how or what, you can explain it in words, but don't give me like this part. But what is a normal, like what is an inverse?
The opposite of a conditional statement.
Yep, opposite of the conditional, so that's going to be not P implies not Q. Any idea how I would negate this?
If the fuse is not blown, the light will turn on.
Yep. If the fuse has not blown, or you can say hasn't blown if you want to shorten it a little bit, then the light will go on. Okay, so sometimes negating is actually undoing something that's already listed as a not, correct? So a conditional statement was the light will not go on. So the inverse of that is the light will go on. Okay, so sometimes it's not putting a not in there, it's actually removing a not. Okay. All right, contrapositive is going to be not Q implies not P. So this would be if the light will go on, then the fuse has not blown. So I know I mentioned this when we were doing 2.1 and a little bit with 2.2, but you've really got to make sure you watch what they're asking for and really watch your wording. There's not really a lot of math involved in this section or these first few sections, but it's all about the wording of how they say things and all of that. So just make sure you're really, really watching that and getting practice when you're doing your problems. All right, open your book to page 92 because the next two problems we're just going to talk about. We're not going to write them. I just want us to talk about deciding if it is inductive reasoning or deductive reasoning. And then basically we're going to explain why we chose what we chose. So we're looking at numbers 21 and 22 on page 92. All right, so looking, yes,
Is that squiggle like supposed to be an N?
no, it means not. All right, number 21. For the past 3 Wednesdays, the cafeteria has served macaroni and cheese for lunch. Dana concludes that the cafeteria will serve macaroni and cheese for lunch this Wednesday. Do you think this is inductive reasoning or deductive reasoning?
Hey,
Hey.
are you able to pick up?
Yep. Hey. Right. I haven't heard anything. I would assume since they're just coming from Hampton, it should be fine. I was wondering that as well, but I think at this point, if we can get it in, we're going to get it in because it's the point where we don't have a lot of open days, so I'm pretty confident. But yeah, I would think I would have already heard because we have to cancel ref so much in advance if we were going to do that. So I don't think it will be an issue. So, yep, thank you. Bye. No, she was just asking because some public schools, like in flood zones, had to close early because of like the water's rising. So some parents that I guess have kids in others, like in public schools, were like, are y'all doing the same thing? And like, are the games still happening? Are we canceling the games? And I was like, I don't think that we would, but
It doesn't really matter because there's no.
well, in where they're coming from, it won't be an issue. Like if it was somebody coming from across the water, yeah, I would say we probably would. But
I do too.
I mean, I know it's been raining all day, but I don't feel like it's been that bad. But I also don't know. I haven't been outside, so couldn't tell you.
It's like back and forth.
Yeah.
I live in Hampton too.
Okay, I'm sorry.
Okay, so let me just read it again. For the past 3 Wednesdays, the cafeteria has served macaroni and cheese for lunch. Dana concludes that the cafeteria will serve macaroni and cheese for lunch this Wednesday. Is this inductive reasoning or deductive reasoning? Why?
Because you didn't have examples.
Yep. They're going off of previous examples to form a conjecture about what's going to happen in the future. So I'm not actually going to write everything down, but I'm just going to write that 21 is inductive. All right, 22. It says, if you live in Nevada and are between the ages of 16 and 18, then you must take driver's education to get your license. Marcus lives in Nevada. He is 16 years old and has his driver's license. Therefore, Marcus took driver's education. What kind of reasoning is that? Which one? Yep. Deductive reasoning. All right. I'm going to pause there and we'll do the last few examples tomorrow at the beginning, and then you'll have time to work after that. I'll probably also tomorrow go ahead and put up the quiz review problems so that if you wanted to get started on them, you could, so that on Thursday you can check your answers with my book after you're done, because we'll have a quiz on Friday on 2.1 to 2.3. Make sure if you haven't turned in your vocab yet, I've gotten a few. I haven't checked anything that's been turned in yet as far as vocab, but make sure you get those back or get those in tomorrow. As far as a vocab quiz, probably looking at like next Tuesday maybe for a quiz on the 18 vocab words. So just be aware of that. These ones are a little easier than the last chapter. Well, I don't know if easier is the right word, but there's less of them, so it's not as much to study. So that will just probably take like 10-15 minutes at the beginning of class, and then we'll just continue on with what we're doing on those days. So anyways, but we'll pick up and finish this section tomorrow just because there's not enough time to finish, so I might as
Okay, we have one
we're at a
more.
good stopping point. No.
Yes!